Okay, so now we have this handy formula. How do we use it to solve a quadratic equation? Let's say we wanted to use the quadratic formula to solve this quadratic equation. 4x squared minus 7x minus 14 equals 0. What do we need to do? Well, the first thing we're going to need to do is to identify a, b, and c. A is the coefficient of x squared. So in our example, a is 4. B is the coefficient of the x term, so b is negative 7. And c is the constant, so c is negative 14. All right, this is a little anticlimactic. Once we've identified them, we plug them in. So the solutions to this equation are x equals negative 7 plus or minus the square root negative 7 squared minus 4. A is 4, c is negative 14, all over 2 times a is 4. All right, what would we do next except do the arithmetic? So negative 7 is positive 7. Inside the radical, I'll have negative 7 squared minus 4 times negative 14 is 273. And then this is all over 8. What's our last step going to be? Simplify if possible. I want to see if 273 has any perfect square factors. I'm going to use my calculator to do the tedious systematically multiplying by every perfect square. Right, so I'm going to look at all the perfect squares and then 273 divided by each perfect square. Looking at the table, 1 of course works, but I don't care about that. I'm looking in the y2 column to see if there are any whole numbers. No. And now I'm to perfect squares that are larger than 273. So nothing's going to work. Since I can't simplify this square root, I can't simplify. I'm done. So using the quadratic formula is actually quite easy. Getting it was hard, but now that we have it, we just plug in. I'm going to give you one of these to try. Use the quadratic formula to solve this equation. Pause the video and try this now. All right, so my coefficients are a is negative 0.3, b is negative 12, and c is 30. Plugging in then, I'll get x is negative 12 plus or minus the square root of negative 12 squared minus 4 times negative 0.3 times 30 all over 2 times negative 0.3. Now I'm going to do arithmetic. 12 plus or minus the square root of 180 all over negative 0.6. I see that 180 is going to have at least 9 for a perfect square factor. I'd like to find the biggest perfect square factor. So again, I'm going to resort to my calculator's tables. Right. Here I'll have all the perfect squares and 180 divided by all of the perfect squares. Oh, no. 180 divided by 225 is 0.8. It looks like the biggest perfect square that goes into 180 is 5. 180 is 36 times 5. Working that out off to the side, root 180 is root 36 times root 5. Root 36 is 6. So this is going to be 6 root 5. I'll have 12 plus or minus 6 root 5 over negative 0.6. Now maybe it's okay to leave this way. I'm not happy about having a decimal or a negative number in my denominator. I'm going to multiply my numerator and denominator here both by 10. Notice the plus or minus didn't change because I multiplied by a negative number. Positive and negative, negative and positive, it's the same thing. And now I see that 6 actually goes into both of the terms here. I'll have negative 20 plus or minus 10 root 5 for my solutions.